In this video, we'll look at question 54 from the specimen paper. In this question, we have a train which consists of an engine and two carriages. We know their masses and also that the engine pulls with a force of 15,000 newtons. We are supposed to find the tension between carriage 1 and carriage 2. To do that, let's first look at the total acceleration of the train. So the force on the train is 15,000 newtons, and we know its total mass, that's 5,000 plus 5,000 plus 20,000 kilos. And from that we see that the acceleration of the train as a whole, but also of the individual carriages and the engine, is 0.5 meters per second. By Newton's second law, force is mass times acceleration, and the acceleration of each of the elements we know as well as its mass. And hence we see that the total force on the carriages must be 2,500 newtons, while on the engine 10,000 newtons. So this total force of 15,000 newtons is split up in the ratio of the masses of the individual parts of the train. If the total force on the engine must be 10,000 newtons, and we have a force of 15,000 pulling to the right, that means that there must be a force of 5,000 pulling to the left. That gives us a total force of 10,000 newtons as required for that acceleration we calculated earlier. But the tension in this string must be the same from both sides by Newton's third law, so the force on this car is 5,000 newtons to the right. But as we know, the total force on it must be 2,500 newtons, in which case there has to be a force pulling to the left of magnitude 2,500. And again, by the same logic, the tension from the string is pulling the last carriage with exactly the required force of 2,500 newtons. So we managed to dissolve this force into the tensions in the individual strings. And the one they were asking about, 2,500 newtons, that's the tension between the first and the second carriage. So our final answer is 2,500, and that was letter A.